Here, we have a little single-player trivia game that uses Phoenix LiveView. You get a question, about Elixir of course, and then when you choose an answer, the game gives you feedback on whether your answer was correct or not. Let's take a quick look at how the feedback works in the app. We'll open the Trivia Live LiveView, and in it there's a handle event callback that pattern matches on the answer event, which is called when you submit an answer to a trivia question in the game. You can see below that it uses the LiveView push event function to push the reveal event to the client with the payload containing the keys status, correct index, and selected index. Now this payload is handled by the answer feedback hook, which mounts when the page loads, and then registers a listener for the server's reveal event we just looked at. The listener then fires reveal payload. This takes the status, correct index, and selected index values from the server and updates the answer choice buttons in our game with the appropriate classes based on the guess: choice correct, choice wrong, and choice dim. It also disables the buttons to prevent another guess. Now, this current structure of our app probably won't surprise you. The server sends data, and then the client decides how to update the UI based on that data. And all the custom styles for our trivia game live in our global app.css. But with the release of LiveView 1.2, it introduced some new features that allow us to organize our code in a simpler way. Let's refactor our trivia app to do a few things. First, let's use server compose JS commands to write the feedback commands in Elixir and then hand them over to the client to run. With LiveView 1.2, Phoenix LiveView JS structs are now automatically encoded when sent with push event, which makes our implementation easier. Then let's use Colocated CSS to write our component styles inside the component. This way, if we need to update the design, they'll be much easier to find instead of having to dig through different CSS files. Or if we need to remove the component, the styles are deleted with it. And finally, we'll update it to use co-located hooks. While co-located hooks aren't new in LiveView 1.2, they're a great feature which allow our JavaScript code to live inside the LiveView. And what's great about this refactor is we'll be able to update our code piece by piece without losing any of the functionality in our app along the way. Alright, let's get started. We'll open our mix file, and then we'll bump the version of Phoenix LiveView to be 1.2. Then we'll go to the command line, and then we'll refetch it with mix deps.update Phoenix LiveView. With that updated, let's open our Trivia Live LiveView. Like we saw in the introduction, our answer handler pushes the payload to the client, and we want to replace that and instead compose a Phoenix LiveView JS command for the feedback and push that instead. In order to do that, we'll first need to alias the Phoenix LiveView JS module. Then, in our handle event answer callback, instead of building a map of raw data for the payload, we'll build up our command here in the LiveView and then push it to the client with a single key command. Now, we'll need a way to build the command, which will be a JS struct that applies the updates in the UI based on the answer. To do that, we'll use a new private function that we'll write called reveal command, and we'll pass in the data that we were sending to the client, whether the answer was correct or not, the correct index, and the index. Now let's implement the reveal command function. This function will need to implement the functionality that's currently in the answer feedback hook. And to move that functionality to our LiveView, we'll use the JS module's client utility commands. Back in our reveal command, I'll go ahead and paste in the functionality, updated to work with the JS commands we saw, but let's walk through what this code is doing. First, we define a CSS selector all that matches all the trivia answer buttons inside the element with the ID trivia, which are the elements that have a data index attribute. We'll reuse this selector as the target for several of the commands below. Then we're creating a base set of commands, starting with remove class to remove any previously applied feedback classes, and then set attribute to disable all the answer buttons. Then we're using add class to add the choice correct class to highlight what answer was correct. Once we have our base commands, we'll create a conditional on whether the answer was correct or not. If it was, we'll dim all the answers that are not the correct guess. And if it wasn't the correct answer, we'll highlight that the user's guess was wrong with add class, adding the choice wrong class, and then we'll add the choice dim class to dim any other answers. We can then push this command as is to the client. We don't have to encode anything here because in LiveView 1.2, the JS struct knows how to serialize itself when it goes through push event. This will update the client UI when an answer is selected, but we'll also need to handle when the user chooses to proceed to the next question. When that happens, we'll want to reset the UI. To do that, we'll update the existing handle event callback that pattern matches on the next event that's sent when the user clicks next question. Inside the callback, we'll update it to take the socket and pipe it into the advance function that it's already using. This resets the question state and advances the user to the next question. Then we'll call push event using the same reveal event, and for the command here, we'll want to reset the client-side feedback, which we'll do with a new function we'll implement called reset command. Just like we did in the reveal command function, we'll define a CSS selector all that matches all the answer buttons inside the element with the ID trivia. Then we'll define an empty JS struct and pipe it into JS remove class to remove any of the custom answer classes that were applied. Then we'll pipe that into remove attribute to remove the disabled attribute from the answer buttons. Great, now we have both of our events, when a user submits an answer and when they move on to the next question, set to update the client through LiveView JS commands. Now we can open our answer feedback hook, and we can update the reveal handler to instead receive the command from the payload and run it with this.js, then exec the command. This applies the server-built JS commands we send over from the LiveView in the browser. With that added, we won't need the reveal function anymore, so let's go ahead and remove it. And then let's ensure the server is running. And now if we visit our trivia game in the browser, great, our app's UI is now being driven from LiveView using LiveView JS commands, and then those commands are being invoked from a stripped-down hook. Right now, all of our trivia styles like the trivia answer buttons and their feedback states live in our global app.css. This works, but LiveView 1.2 gives us a new feature, Colocated CSS. With Colocated CSS, we can write a component styles inside the component. This makes it much easier to find and change styles. Let's update the trivia answer styles to use Colocated CSS, but before we can move our styles, we'll need a component to move them to. For our component, we'll move the trivia answer button to be its own function component. We'll define a new function answer choice and pass in the assigns. Then inside, we'll copy over the button element from the Trivia Live template and paste it into the answer choice function. Then we'll update this to work with our component. We'll remove the for attribute, and then let's update it to use the index assign and the choice assign. Then we'll need to declare them as attributes for our component. And now let's go back to our Trivia Live template and update it to use our new component. We'll render a new answer choice button component for each choice, passing in choice and index as attributes. Great, now let's move over to the CSS. Let's open our app.css and we'll copy all the trivia answer choice and feedback classes. Then we can go back to our answer choice component and we'll define a new style element with a type that points at a small strategy module that decides what to do with the styles. For ours, we'll name it myappweb.colocatedcss. Then let's paste in our copied styles. Perfect. Now let's create that strategy module. LiveView Colocated CSS gives two examples here. Global CSS, which is extracted as is, and Scope CSS, which restrict the elements that the CSS rules apply to only the elements of the current template or component. For our example, we'll use global CSS. We'll create our colocated_css.ex file, and then define the module. Then we'll use phoenix.liveview.colocatedCSS to pull in the colocated CSS behavior. Since we're going to use global CSS, all we need to do is implement the transform callback, so let's copy that, and paste it into our colocated CSS module. With that added, we can go back to our app.css and remove all the styles that we moved to our component, and then tell our CSS pipeline about the extracted styles. LiveView writes them into the Phoenix colocated folder. We'll want to pull them into our app.css with an import. And with those changes, let's go back to the browser. And perfect, everything works exactly the same. But a trivia answers markup and styles live together in one component instead of being split across two files. And if we ever need to make updates to the design, it's easy to modify, and if we ever delete this component, the CSS goes with it. Now that our UI logic is driven by LiveView.js commands that live in our LiveView, and our component styles are updated to use colocated CSS that live in the component, let's make one more change and move our JavaScript hook into our LiveView 2. This way, all the markup, styles, and JavaScript will live in one LiveView. While colocated hooks aren't new to LiveView 1.2, they shipped in 1.1, colocated CSS is built on the same foundation and uses the same concepts. Let's open our Trivia Live template, and we'll define the hook at the bottom of the template with a script tag, and then we'll add a type of phoenix.liveview.colocatedHook to identify it as a colocated JS hook. We'll need to give it a name. Let's call it .reveal. The leading dot tells LiveView this is a local colocated hook, and it gets namespace to this module under the hood. Then let's open the answer feedback.js hook and copy the code, and then move it to our template. Now that it's a colocated hook, it's named by the name reveal attribute, and LiveView picks up the script's default export for us. So instead of a named answer feedback export, we'll just export it as the default. And then let's find where we have the Phoenix hook set to answer feedback and change it to use the .reveal colocated hook. Now that our hook is updated, we no longer need the answer feedback hook, so let's remove it. And then let's open the app.js, and we'll remove the answer feedback hook there too. Now let's go back to the browser and play one last round. And great, everything is working just like it did before we started refactoring our app. Now our app.js doesn't register any custom hooks, app CSS has no trivia styles, and everything about the answer submission logic, its markup styles and behavior, live in one LiveView. Our app.js now doesn't register any custom hooks, app.css has no trivia styles, and everything about the answer submission logic, its markup styles and behavior, live in one LiveView. Well, that's it for now. Thanks for watching and happy deploying.